My grandfather, he used to be a farmer up in Michigan. He was also a pretty adventurous guy as well, and apparently he found a Time magazine once, came home to the house at one point when my dad was about 15, and he said, there was a feature on Australia, and he says, let's go, this looks like fun. They packed the farm up and went out to Australia and started farming out in Australia. And I grew up working my school holidays on the farm, driving tractors, working with cattle. And I think that's given me definitely an appreciation for, first of all, where my food comes from and the effort it takes, but also the importance of farmers in the ecosystem of how we live. And so I really have a lot of time and respect for what the farmer does. Why am I here, right? Like, what brought me to the University of Southern Mississippi? I get asked that question a lot. You're from Australia, why did you come here? And I think, okay, I'm invested in education, right? I am trying to teach students here at the University of Southern Miss. My research is focused on biomaterials and biomedical outcomes and health-related research. Well, if you think about, where I should be, and we look at sort of US metrics around where Mississippi currently sits in terms of education and health outcomes in some really important diseases, well, it's exactly where I need to be, right? This is where I can have some impact from an education standpoint, trying to help the next polymer scientists and polymer engineers get out there and do great things, but also from a health-related standpoint, I can work on research that is important to Mississippians, right? And that's the piece that I really like about being here, and that's definitely what drove me and my family to take this position and take this challenge on. My lab here at the School of Polymer Science and Engineering at the University of Southern Mississippi, we work primarily on using polymers for tissue regeneration and drug delivery applications. So we're the biomaterial lab in what we do. One thing that we're doing that we think is really exciting is our work trying to develop polymers or polymeric materials that can help with tissue regeneration following burn injuries. So we work on developing materials for burn regeneration, and to do that we actually work with a technology that takes a small sample of a patient's healthy skin after they maybe have a burn, and they digest up all the extracellular matrix, which is all the pieces that hold those cells in place of that healthy skin. We then take them up in a syringe and then spray them back out over the wound to try and regenerate that skin where the burn might have been initially. The challenge with that is twofold. Sometimes you don't have enough cells that you can gather to then redo that. And the other part is if you're trying to spray that over fingers or nose or ears, for example, the cells you spray out don't stay where you've put them. So we're trying to develop polymeric materials that can be sprayed with those cells and create a scaffold that helps actually hold onto those cells and promotes the regeneration of the skin following burn injuries. It sort of creates this infrastructure that the cells need to be held into so they can actually then regenerate effectively. And I like to think about this, if you're trying to rebuild a building, for example, and you want to fix all the windows as you're going up to the 5th floor, well, you can't do that from the ground. You can't put all the cells or all the people, the workers, on the ground floor. You've got to build the scaffolding up the side of the building so they can get their way up to the top and actually then work together effectively in a team, and the cells in your skin are no different to that. Currently we're focusing on burns, and that's because of the device that we're looking at that sprays these materials is already approved by the Food and Drug Administration, the FDA, for burn treatments. But there's a whole range of areas where this could be useful for. Thinking about surgical wounds even, just going in for surgery, you have scar tissue that forms, that can impact your quality of life. Thinking about diabetic ulcers, a massive problem here in Mississippi is diabetes. How can we look at treating some of these scenarios where that's a chronic wound, has problems with infection and those things, but we're all in the business of wound healing, and we think there's a great market and opportunity for our technology to diversify away from burns and have impact in these spaces as well. The problem with burns is the burn surgeons are getting really good at what they do on their side. So people can survive now after horrific burns, talking about total body surface area coverage of 60% and above, which is a significant amount of burn injury. The problem is if that skin doesn't heal properly, it turns into scar tissue. Scar tissue over that sort of area starts to really affect quality of life, and the ability just to have a cup of coffee or to eat your dinner effectively with a knife and fork becomes really challenging. The Smart Mississippi Business Accelerator Initiative has been really good at thinking about taking what we've been doing on the bench side in the chemistry lab and saying, okay, now we really want to try and think about the translation pathway for this work and trying to get it to the patient. That can be a really rocky road and can take time. And so one thing for burns especially that's important for us is we need to be able to test these things in the right models so that we can actually prove to something like the FDA that our technology has value, right? And so to do that, we've been actually working in piloting some of this work in a pig injury model. Pigs are the best model for us because their skin heals by the same mechanisms as humans, so it's the right preclinical data we need to get to be able to then go and justify to the FDA that we think our materials have promise in this field. And so the funds that we've got from the Mississippi Smart Business Accelerator Initiative has been instrumental in allowing us to actually start to progress that towards hopefully getting the data package we need to be able to present that to the FDA and try and get this into the clinic. Alongside doing my role here as an assistant professor in the School of Polymer Science and Engineering, I also play field hockey at a pretty competitive level. And so fortunate enough to play field hockey for Team USA as their goalkeeper, and have represented them at some tournaments in the past, and looking forward to continue to do that as well. I think it's important to be able to show students that you don't have to just be a scientist, you can do other things as well. And the ability for me to be able to combine science and elite sport, there's actually a lot of similarities between those two things in terms of being resilient, teamwork, being disciplined. And I think those things have lessons for each other. And I like being able to, pursue both of those things, and being, fortunate to have a very supportive environment here at the University of Southern Miss to allow me to keep doing that.